Okay, dear students, we are doing the practice paper for today, for 2027 A-level batch. So today we have 10 questions to discuss. 3 of them will be from chemical calculations, and the other 7 questions will be there from your first lesson, atomic structure. And I'll show you the paper that we are going to discuss today. And like last week, I have your answers with me. So I'm going to use them to do an effective discussion with you. Look at the first MCQ. This is the newest theory we learned in our last week about balancing nuclear reactions. So can anyone tell me what is the purpose of learning this? Related to which experiment or which theory we needed this? Yeah, Chadwick's experiment. Okay, it's not regarding the gold foil experiment, it is regarding the Chadwick's experiment. Okay, in Chadwick's experiment, uh, Chadwick discovered neutron. So during that, alpha rays were radiated on beryllium or boron metal sheets. Okay, so during that process, when alpha particles colliding with beryllium or boron atoms, there was a nuclear reaction happening. That's how it give off neutrons. Okay, so to explain that thing, what happened during the Chadwick's experiment, we learned the nuclear reactions. Okay, so I hope you all have the paper with you now. So please write near the nuclear reaction what is the purpose of learning that one in A-level chemistry. Okay, just say to explain what happened in Chadwick's experiment. Okay, shall we first of all write that? Because whatever the thing we learn, Lamai, there must be a relationship. Okay, there must be a reason why do we learn that one. Okay, so we needed nuclear reactions. So we needed nuclear reactions, balancing nuclear reactions to understand Chadwick's experiment. Okay, Chadwick's neutron discovery experiments. Okay, so that is why we needed this one. Now let's see how to do this question. Okay, so it's asking which of the following nuclear reactions is balanced. Okay, so there are 5 nuclear reactions given. We have to figure out which one is truly balanced. Okay, so let's check what is your answer. Yes. Okay, now I can see there are 20 responses for the paper. So all of you, all the 20 students have answered the question correctly. Okay, so that means third one is the balanced nuclear reaction. Okay, so very good. So that means you all have understood the question properly. Okay, and the theory properly actually, right? So the what we did last week is good, right? So still I'm going to explain, so let's take the third one. That is our answer. It's uranium 92 234. That one gives you TH means Ramai thorium 90 and 230 going to give you an alpha particle. Alpha is 24. So that knowledge is also needed. So they have just given it is alpha. So you need to know that is alpha 24. Okay, so it's basically helium nuclei. Right, so what is the sum here? 90 plus 2, it is 92. So that means this number we call it as proton number, and this one is called as the nucleon number. So during nuclear reaction balancing, you need to have the both sides should have the same nucleon numbers, sum of the nucleon numbers, and both sides should have the same sum of the proton number. So look at here, it gets 92, which is equal to this number, and nucleon numbers will also get you 234, which is equal to the left side nucleon number. So this reaction, this nuclear reaction is balanced. Okay, this nuclear reaction is balanced. Right, then you can go to the other questions and check whether why those reactions are incorrect. So I'm going to write them really quick here. So let's take the first one. It is palladium 91 and 229, and it is going to give you NP 93 233 and an alpha particle, alpha 24. So now look at this. if you get the sum of the new proton numbers here, it's going to be 95, but in this side it is 91. Okay, so that's why the first one is incorrect. Then you can again go to the second one. 90, 234. You go to the other side. Okay, so it's 91 and 233. But still we have to check the other particle. It is a beta particle. So beta particles are basically electrons when it is emitted as radiation. So it is having a -1 charge and negligible mass. Okay, so if you get the proton number sum, it's going to give you 90, which is equal to this value. But if you get the nucleon number, it is going to be going to give you 233, which is not equal to the left side. So therefore this one is wrong. So like that, analyze and write something, give a reason why each answer is not going to be the balanced one. Okay, so our balanced one is the third answer. Okay, so about fourth and fifth also we should write something. 88, 230. It's giving you 88 and 228, and it is telling you it is releasing 2 gamma particles. So gamma particles are having no charge and no mass. They are electromagnetic radiation. Understood? So then you can see obviously proton numbers are okay, but neutron numbers are not balanced. So it's going to be wrong again. Fourth one. And fifth one also we can check in the same way. 89, 227. Okay, so these all are radioactive decays. You can see it is not colliding with any particle, but still it is breaking into several particles. Okay, so we call these as radioactive decays. So again a beta particle, -1 and 0. You can see the proton numbers are not going to get balanced. So it is going to give you 87, but in the left side you have 89. So again fifth one is wrong too. So anyway, all of you have answered. Those who answered for the question gave the answer properly. So that's very good. Okay, so keep going, right? And let's do another question next day also in our next paper class, just to remind the same theory again. Okay, and in your first term test also that I'm going to give you, there will be a question from this. Okay, right, so not a difficult one, it's very simple, but understand the logic and why we are learning that. Okay, that's very important, right? So when you are coming tomorrow means the ISM students, they are having the class on Saturday, no, and the other 2 classes are keeping on the next day. So when you are coming to my next class, please bring the color printout I gave you. Okay, so about the summary of the first lesson. So now we are in the kind of the middle of the lesson, so it's very nice to see what we did and what we are going to do. Okay, so bring the color print with you to your next class, will be helpful. Okay, one more thing to complete our discussion. So about this Chadwick experiment, Chadwick used beryllium and boron metal sheets for the discovery of neutron, right? So the experiment, so the reaction that I'm going to tell you here. So let's write it for beryllium. Beryllium 4, 9. And when you are attacking that nuclide with the alpha particle, alpha 2, 4, just write it down for the sake of understanding this. This is the reaction we want. Okay. And there is a reaction for boron as well. It is already there in your book. No? So for the paper review, put this one. And during this nuclear reaction, it's going to give you carbon 613. Okay. So 612. And going to give you a neutron N01. Okay, see here 9 plus 4 13, 12 plus 1 13, and here 4 plus 2 6, and here 6. So this is the nuclear reaction happened when Chadwick used the beryllium sheet. Okay, so to understand what happened here, how the neutron was given, just to understand that, we are learning the nuclear reaction balancing in this lesson. That is the reason. Okay, so like that, when I'm teaching anything, okay, basically anything in the syllabus, so I'm going to tell you why you are learning that, so then you will remember it for a long time. Okay, so remember we are learning, we are in 2025, but you are going to write the exam in 2027, so 2 years from now. Okay, so we have to arrange our notes, questions and everything what we learn in order to be ready for the exam. Okay, right, so let's go to the next question. Next question. So it's a chemical calculation, right? So let's see that one. We started this last week about the new topic, limiting reactants. Okay, limiting reactants. So it's the second part of stoichiometry calculations. So now, for so far, now you are given 3 tubes from chemical calculations. Okay, 3 papers. Okay, so third paper was given last week, and when you are coming to the next class, please bring the limiting reactant tube. Okay, because we have to complete the rest of the questions, and we did only 1 or 2 questions in the class. So from this next few classes, we are going to complete the tube. Okay, we're going to complete the tube, right? So this question, the second one and especially the third one, will be a good revising about the theory we learned in the class. Okay, about the limiting reactant. Right, now first of all, let's go to the answers. So the answer I gave you is answer 1. So let's check how many of you got the answer correctly. Yeah, out of the 20 responses we are having, okay, now there are more than 60 students in the class, so only 20 have submitted the answers, right? But there are a few more questions to discuss, so still if you haven't submitted, please do it. Okay, so then the sample will be bigger, right? So then our inferences will also be accurate, right? Okay, so first one has selected by 12 students. It's very good, and some of you have selected other answers as well, but we can't just take any idea. Some of you have selected the third one. Okay, but still maybe simplification errors and issues. Okay, we'll see. So majority has selected the correct answer. That's very good. Okay, now we'll explain about the second question. Okay, so look at the question one more time. This is your second question. Okay, so I'm going to prepare a small diagram. So it's telling you a reaction between NO gas, and O2 gas, and the product is NO2 gas. So it is not balanced. Okay, we have to balance it before we start the question. And the data given 0.2 moles of NO, and it is kept in 4 decimeter cube vessel at 27 Celsius. And about O2 also data given. It is again another 0.2 moles and still at the same temperature 27 Celsius, and the volume of the container is 2 decimeter cube. Now they are telling us the 2 containers are joined. So when they join, it says they react completely. Okay, they react completely until the limiting reactant is reached, and the volume and temperatures are not changed. They are asking the final pressure. Okay, so first of all, we have to understand, Lamai, when you join the 2 containers. Okay, so when you join the 2 containers, there is a 4 decimeter cube vessel and there is a 2 decimeter cube vessel. So when you join the system, when you join the 2 vessels, it becomes a system of 6 decimeter cube. This concept is really important, so understand it before doing the question. Okay, now let's go to the board and try this one. When you join the 2 containers, remember it becomes 6 decimeter cube, the total volume. So this is the total volume. So when you find the total pressure or the final pressure, okay, you have to consider 6 decimeter cube. Okay, so now first of all, we have to balance this reaction. So what you know up to now is balancing reactions using the inspection method. Okay, what is inspection method? You observe the 2 sides, you observe the reactant side and you observe the product side, and you put some number in front of the chemical reactant. in order to balance it. Okay, so about this, you can see now oxygen atoms are not balanced. Here you have 3 and here you have 2. Okay, so we can't put fractions now. Therefore, I can put number 2 here and number 2 here. Then you can see 4 oxygen atoms in this side and 4 in this side also. So there is no right way of doing this one. It is kind of trial and error. You put some number and you check whether it is okay. If it is not, you put another number, like that. So with the time, with the practice, it will get better. Okay, so let's keep doing questions. Okay, someday if you haven't got this inspection method right yet, don't worry, keep doing questions and keep repeating the questions we did earlier. That is also very important. Okay, right? So here's how you are balancing it. You put number 2 in front of NO and 2 in front of NO2, right? And you have been given data regarding 2 reactants. Remember what we learned last week? If you are given data regarding 2 reactants or more than 1 reactant, that may be that question should go according to the limiting reactant theories, because we don't know what chemical reactant will be fully consumed. Okay, remember the stoichiometry questions? There you are given about the data about only 1 reactant, and it is normally telling if there is another reactant, they says it is added excess, right? But here they haven't tell you anything regarding excess or anything. They just tell you we have NO 0.2 moles and we have O2 0.2. That's it. That means we need to find what is the limiting reactant, because limiting reactant is the reactant that stop the reaction at some point. Okay, so to do that, we have a method, we call it as added reacted remaining. In short, we say ARR method, added reacted and remaining. ARR method, added reacted remaining, ARR. Understood? So now let's write how many moles of NO is added. 0.2. Here another 0.2. We haven't had anything from NO2. Okay, so then these things are reacting according to their stoichiometry ratio. So what is the stoichiometry ratio here? What is the stoichiometry ratio here between our NO and O2? The stoichiometry ratio is 2:1. They are reacting in 2:1 ratio. 2:1 ratio. Okay, so that means very simple maths lah. So from NO and NO2, 2:1. That means if you have 0.2 moles of NO, you will only need 0.1 mole of O2. Understand? But you have added more than that. Okay, so that means our O2 is what? Is added excess. Is that clear? O2 is added excess because we need only 0.1, but they have added 0.2. Okay, so now the reacted amount will be 0.2 from NO and 0.1 from O2. So when you are writing the reacted column, you are focusing on the stoichiometry ratios. Okay, and from this side NO 0.2 is formed. To indicate that they are formed, we write plus sign. To indicate that they are consumed, we write the minus sign. That's the thing, right? So when you get the remaining, you subtract them. So you can see nothing will remain from NO. That means it is completely consumed. In other words, we can say what? It is a limiting reactant. And from O2, only 0.1 will be remaining. And here 0.2 will be there. Right? So by the end of this ARR method application, what you can find is the remaining moles of excess reactant and formed product. Okay, so how many total moles are remaining? 0.3 total moles are there. And Lamai, this 0.3 moles of gas will create the final pressure. Understood that? This 0.3 moles of gas will create the final pressure. Okay, the final pressure. So now we have to find out what is the final pressure. For that, We are applying an equation. What is that? PV equal nRT. PV equal nRT. So that equation actually you will be taught properly in unit 4, but still we are using that one when we do this chemical calculation. Okay. So what is that equation? PV equal nRT. So we need to find the pressure. So it is nRT over V. Okay, nRT over V. So I'll write it somewhere else. nRT over V for the final mixture. Final. So total moles 0.3 will be there, and R value 8.314 joules per mole per Kelvin. So that constant value you will be given in the exam, right? And the temperature you have to apply in Kelvin, 300 Kelvin. We have done several questions from this topic about PV equal nRT. So I hope you remember the logic and the principles behind that. We must apply in SI units, okay? So we have to put here the final volume, which is 6 decimeter cube, but we have to convert it into meter cube in order to get the answer in moles, okay? Right. So after that, we can simplify. So I'm going to get the numbers here with a pencil. Cut this one, huh? And here 2. Here you have 0.1. You carefully simplified this. You will have 8.314 into 300 into 300 into 300, and I'll take the 100 out, and there is a 0.1 also. Okay, and it will be like 10 to the power 1 here, and 6, sorry, not 6, 2 into 10 to the power minus 3. Okay, so when you simplify this, so it's if you multiply 8 into 3, it is going to give you 24. 24 division 2, you will be getting somewhere around 12. Okay, so 12 something into 10 to the power 4. That means 1.2 something into 10 to the power 5. Okay, so that's how you get the answers. There's only one answer giving like this. Okay, look at the answers, Lamai. 1.24 into 10 to the power 5. That is our answer. Is that clear? So because other answers are having different decimal values. Okay, look at this one. See the answers. 1.24, 8.64, like that. So 8.64 can't come, and 1.72 is also not applicable. You can understand that 1.7 something will not come. So it must be 1.2 something, right? Then there are only two answers. If you just properly get the decimals, you will get the answer. Okay, so what is the summary here? You, first of all, Lamai, look at the data given and arrange them properly. And if they have given a chemical reaction, write it also. Then it might not be balanced. Right? Then you have to balance it again. Balance the chemical reaction. So after balancing, check how many moles of each compounds are given. So you can see NO 0.2, O2 0.2. Right? So after balancing, you will see 2 to 1 ratio. That means 2 moles of NO will react with 1 mole of O2. Right? But you have added 0.2. That means you need only 0.1 mole of O2. Right? 0.1 mole of O2. So considering that, you find the limiting reactant. Limiting reactant is NO. So NO will be fully consumed. You can write like this. And O2 only 0.1 will consume. And from NO, 0.2 will be formed. Then you get the remaining values will be 0.1 from here and 0.2 from here. So 0.3 total moles will be remaining. That will give you the final pressure. For that, you apply PV equal nRT. Okay, see how it is coming. And then you write like this, simplify. There you have the answer. And I'm going to show you one thing. And this is a small trick, Lamai. and you have to be really careful when you are applying this. හරි මම පොඩි ට්‍රික් එකක් පෙන්නන්න සිම්ප්ලිෆිකේෂන් එකට. හරි මම මේක තාම කරේ නැහැ. but ඒ කියන්නේ theory class එකේ කියපු නැති එකක්. එන්න පොඩ අහගන්න. You can only add this one for MCQs only. Right? Don't ever apply it for essay question. Huh? So this 8.314 is a little trouble here no? During the simplification. Okay. So we are kind of a lazy people, right? So we have to find a solution, a quick way to simplify this. So we can write this 8.314 like 100 over 12. It is almost equal to 100 over 12. 100 over 12. Okay, just divide 100 over 12 and see. Okay, you will get 8.333. So it's almost like similar, right? It's not equal, but you can use, instead of 8.314, you can use 100 over 12. Okay, then it will help you for the simplification. Okay, so now let's do this one here by using that value. Okay, so what do we have to simplify? 0.3 into 8.314. So I'm going to write it 100 over 12, and the temperature is 300 Kelvin, and our volume is 6 into 10 to the power minus 3. Okay, now let's simplify and see. So you can cancel this 3, so it's 0.12 here, and you can cut this one also, 100, and here you can cut like 4, right? 4, and yeah, then your answers will be, now it is kind of easy to simplify lama. Okay, so in the numerator you have 1000, in the denominator you have 4 into 8 and into 10 to the power minus 3. So if you put it above, it will be 10 to the power 5. It is 10 division 8 into 10 to the power 5. So it's going to be 1.2, okay, 1.25 into 10 to the power 5. Understood? It's very close to our answer. Do you see Lamai? For the MCQs, you can use that. Right. What about the third one? So third question. Okay. So aluminium metal reacts with MnO in suitable conditions to make Mn metal, manganese metal, as follows. So the reaction again not balanced, and it is telling you masses of aluminium and MnO, manganese oxide. Okay. So again you can understand it is the two data are given. Okay, so data are given about two reactants, so it must be from limiting reactants. It must be from limiting reactants. So we need to figure out which one is the limiting reactant and how many product moles are given. But do you see some additional thing is there? Additional thing is there. It is asked in the percentage yield of Mn, manganese. So percentage yield, I have defined you that one. That is a new thing for you. Percentage yield is actual yield over theoretical yield. Okay, so actual yield is 180 grams. That it is telling here. Did you notice here? 180 grams is the actual yield you got, and you can calculate and see how many manganese gram will be given. That is a theoretical yield. Theoretical yield is the mass of magnesium you are getting from ARR method. Then apply them, simplify and see. හරි මම පොඩ්ඩක් ආයෙ කියන්න. මේක අලුත් එකක් ළමයි. percentage yield එක කියලා කියන්නේ හරිද? අපිට ඇත්තටම හම්බෙන yield එක තියෙන්නේ. ඇත්තටම හම්බෙන එක කියන්නේ දැන් මෙතන මෙයාලා කියනවා මේ reaction එකෙන් manganese හදාගන්න මේක කරන්නේ. but මෙයාලා කොච්චර කරත් ඇත්තටම හම්බෙලා තියෙන 180 grams. හරි 180 grams. එතකොට ඒක තමයි actual yield එක. Then you have to divide that one by the theoretical yield. Theoretical yield කියලා කියන්නේ අපි expect කරන yield එක. දැන් මේ reaction එකේ aluminium and manganese oxide react කරලා අපි expect කරනවානේ gram ගානක්. දැන් අපි ARR method එක දාලා හොයන්නේ මෙන්න මෙච්චර manganese moles ගානක් එයි කියලා. අන්න ඒක gram වලට convert කරන්න. That is your theoretical yield. Okay, then plug them into this formula and get the answer. This is just like how a student score for a test. Then teacher is giving you 100 questions, let's say 100 questions, but students is only getting correct answers for, let's say, 70. Okay, so 70 is the actual yield and 100 is the expected yield. Okay, so if you put it as a percentage, you get 70%. Understood? Okay, so that is similar here. So you expecting manganese some value, you need to find it how much, and you are actually getting 180 grams. Okay, so when you are doing the question, we will see the method. And there is a similar past paper question came from this also. We are going to do it in our next physical class. Okay, right. So I'm going to write few things in the board. But first of all, shall we see how many of you got this correct? The third question, really nice. 18 people got it. Aluminium and MnO going to give you Al2O3 and Mn. So first of all, let's balance it. Let's balance it. So you have 2 aluminium here. You have to put 2 in front of this. Then you have 3 oxygen. You have to put 3 in front of this, and you will get 3 manganese. Okay, so that's how you are balancing using inspection method. So 2:3:1:3 is the stoichiometry ratio. That means 2 moles of this aluminium reacts with 3 moles of manganese oxide to give you 1 mole of this and 3 moles of manganese. Something like that. Okay, so they have given you the masses. They have given you the masses. So let's find out how many moles are there. How many moles are there? So moles of aluminium, 108 grams. We have divided by the molar mass of aluminium, which is 27 grams per mole. Okay, so it's divisible. So 24 times 27 times 2 is 54. 54 times 2 is 108. So basically you have 4 moles here. So aluminium, you have 4 moles. Then find out how many moles of MnO are there. So it is 497 grams. So manganese oxide molar mass we have to find out. It is 55 plus 16. So 1 and 71. So divided by 71 grams per mole. Okay, so now just think 7 times 7 is 49. Okay, so 71. So 70 times 7 is 490. And there is another 7 here. That means it must be 7 moles from MnO added. So this is the added row in our ARR method. So let's find out how many moles of them are reacted. So now let's use the stoichiometry ratios. Okay, now let's use the stoichiometry ratios. Okay, see, if 2 moles of this is reacting with 3 moles of this, right? And let's say how many will react with 4 moles of this. Okay, so see the ratio. With 4, how many moles of MnO will be reacting? So how do we get it? Here, what you have to do, okay, so divide this by the on stoichiometry, which is 2. So I'll show you it here. You have to divide this 4 by the stoichiometry of the on compound and multiply by the required compound. This is the theory you learned that day. Remember, Lama? Divide from the stoichiometry of the on compound, which is 2, and multiply from the required compound. Okay, so you will get it as 2 into 3, 6. So it's direct proportional, but if you are having a trouble with mathematical things, follow that method I showed. හරි මේ ඔක්කොම ලියලා තියෙන්නේ පොතේ පුතේ right ඒක අපිට ස්ටඩි කරන්න අර තියෙන එක්කෙනාගේ stoichiometry එකෙන් divide කරලා අනිත් එක්කෙනාගෙන් multiply කරන්න. Okay, so divide by the stoichiometry of the given compound, that means 2, and multiply by the required compound. Okay, so then in the other way around, if you see, when you want to react all 3 moles of this, you need 2 of this now. That means if you want to react all 7, how many moles of this will be reacting? So 7 division 3 into 2. Okay, so it's not obviously divisible. So 14 division 3 means somewhere around 4.8 4.66. 4.66. So we don't have 4.66, right? We don't have 4.6. We only have 4. Therefore, our aluminium is the limiting reactant. Remember, aluminium is the limiting reactant. So we can write two sentences for this one. In your theory class, I gave you, we did those questions, and let's write a sentence for this also. Right? So let's say this about this. To react with, there are two sentences, okay? To react with 4 moles of aluminium, 4 moles of aluminium, we need 6 moles of MnO, right? So we have MnO more than that, okay? So therefore, MnO is excess, aluminium is limiting. Okay, so that is one. And the other sentence, we are talking in the sense of MnO. So we are going to write like this: to react with 7 moles of MnO, 7 mole of MnO, we need so 7 division 3 into 2, which is going to give you 4.66 moles of aluminium. But we have only 4 moles of aluminium. But we have only 4 moles. Therefore, aluminium is not enough. In other words, we can say it is the limiting. So like that, Lamai, in both ways you can understand aluminium is the limiting reactant. Okay, is that sentences clear to you all? Okay, so according to the discussion now, 4 moles of aluminium is reacting along with 6 moles of MnO. So it's going to form 2 moles of this with the stoichiometry, and it's going to give you 2 times like that, 6 moles of manganese. Okay, 6 moles of manganese. So this is what we are expecting. So 6 moles of manganese is expected. This is the expected yield in moles. Okay, Lama. So is it clear to you all up to here? So aluminium is the limiting reactant. If you check your answers, you can ignore 2 answers, 1 and 3, because they are telling MnO is the limiting. Okay, right. Then we have to check the percentage yield of manganese, percentage yield of manganese. So if I complete this side, so the remaining will be 2 and 6 moles. So we need to convert this one into grams. Okay, so what is the expected Mn mass? So 6 moles into molar mass of manganese, which is 55 grams per mole. So 110, 330 grams are expected. 330 grams are expected. You can just keep it without simplifying. Let's keep it without simplifying. Okay, 6 into 55 grams. Okay, right. So now let's find percentage yield. So these formula will be not given in the A-level exam. Okay, so you have to remember what is the percentage yield. It's not that difficult. Like I said, it is similar to how you are getting marks in a test. Okay, so we get the actual mass. Actual mass is 180 grams. It is given in the question as a data, and expected mass 6 into 55 grams, and we are going to get it for 100%. Now you can see it is divisible. 3, it's going to give you like 30, or you can say, or you can cut this as well by 5. It's 11 and 6, Okay, so 600 division 11. Okay, 600 division 11. So for 50, 60 you have 5, 55, and for 54.5 will be given. If you just simplify it, you will get it. Understood? So our answer is going to be the second one. Second one. So it's a nice question, nah? Just look at one more time. So these are the two most important questions in our paper. And in last few weeks, I did these chemical calculation questions to the end, but I thought of doing them at the very beginning, so you all can get the benefit out of the out of this one, right? So what are the questions you have? Right. So that's the third one. Answer two. So now we are having some small questions. We'll go through them as well. Fourth one is a chemical calculation, but that is actually there to revise you the earlier theories. Okay, let's see how many of you got the correct answer for the. Yeah, okay, really good. Really good. 19 students got the correct answer. I can see that you are getting the benefit from our effort. Right? It's a really good thing. අපිට මේ වැඩේ කරගෙන යන්න තව ආස හිතෙනවා ඕගොල්ලෝ හරියට මාක්ස් ගන්නවා දැක්කාම. Okay ළමයි. ගොඩක් හොඳයි. හොඳේ. You are really good. And please show your reviews, okay, in the class. The mass of a mixture containing ammonium carbonate and an inert substance. That's really important. Inert substance is there. So that means the total mass is 25.0 gram. Okay, 25.0 gram. Okay, that is important thing to tell you. I'll tell it in few minutes. Then you are thermally decomposing that one. That means you are heating that one until it gives you are heating that one until it gives you a constant mass. The reaction happening is you are getting ammonia, water, and carbon dioxide. Okay, so it says 4.4 grams of carbon dioxide is given. They're asking the mass percentage of ammonia present in the solution. Okay, now let's quickly see that one. Think you saw the answer question. Yeah, okay, right. So there is a very important thing here. I think this is the first time you are seeing it in a question with me. හරි මේ පළවෙනි පාරට ඔයාලා මේක දකින්නේ මාත් එක්ක. හරිද? හොඳට බලන්න. Now this sample is not a pure sample of ammonium carbonate. That sample contains some inert substance also. What is the inert substance? Inert substances are that do not participate in chemical reactions. They are just there to contribute to the mass, but they don't chemically react. Okay, so inert means do not chemically react. Chemically react. Understood? So only chemically reacting thing is ammonium carbonate. But since the inert substance is also there, it is the total mass given. Total mass is 25. Okay, so don't ever do this mistake. Don't ever divide 25 by the molar mass of ammonium carbonate. That is fully wrong. I hope you understand that one by now. Don't ever do this one. This is wrong. Because you can't divide like that, no puta. Because 25 gram is the total mass. We don't know the ammonium carbonate mass yet. Okay, so we are simplifying this one to find the ammonium carbonate mass. Okay, so just understand that. So if you are stuck in the question, that may be a good reason. Okay, right. Then see, you are having 4.4 grams of carbon dioxide, but don't be hurry. Just try to balance it first. You are having 2 ammonium. So here ammonium 2 is there. So you have to put 2 in front of ammonia gas, and then it will be balanced. Okay. So let's find out how many moles of, so the mass of CO2 is given. Mass of CO2 is 4.4 grams. So let's find out moles of CO2. Moles of CO2, which is equal to 4.4 division 44 grams per mole. Okay, 44 is the molar mass of carbon dioxide. 12 plus 16 into 2, 16 and 16. So it's going to give you 4 and 44, right? So you are having 0.1 moles, 0.1 mole. So then find out how many moles of ammonium carbonate is there. Now you can see the molar ratios are 1:1. See, 1 ammonium carbonate, 1 carbon dioxide. Okay, since they are 1:1, you will get 0.1 mole of ammonium carbonate here. So we need the mass of ammonium carbonate, not the moles. Okay, so what do? We multiply this 0.1 mole by the molar mass of ammonium carbonate. So ammonium carbonate, so there are 2 nitrogen, so 28, 14 into 2, and there are 8 hydrogen, 8. And I told you earlier, carbonate, remember it as 60. Okay, so then edit 96 is there. 96. So 96 is the molar mass of this one. So you will get 9.6 grams. 9.6 grams. And see, Lama, out of 25 grams we had initially, only 9.6 is what? Ammonium carbonate. The rest is inert. Okay. So to find the percentage of that one, what should we do? You should divide this 9.6 by 25, that's the total mass, and put it into 100%. It's basically 4 times 9.6, 9.6 into 4, 24, 38.4. So you are having an answer called 38. So that should be the correct answer. Okay, very good, very good. Okay, so any problem with this one? This is basically stoichiometry. හරි දැන් මේ වෙද්දි මේ වගේ questions ලේසි වෙන්න ඕන. කට්ටියට කියන්නේ තාම අමාරු නම් අවුලක් නැහැ උදේ හදලා practice කරලා ගත හැකි. But මේ ටික බලන්න දැන් shape ද කියලා, set ද කියලා. These are the questions we tried earlier. And like I said, this is the most difficult lesson you are having in your first and second terms. ඒක ඔයා දැන් හරියට මාත් එක්ක මේ කරනවා කියන්නේ පැටලි හරි කමක් නැහැ. හරි මම කියන්නේ 100% යන්න ඕනේ නැහැ. ටිකක් හරි තේරුම් ගන්න බලන්න හැමදාම. ඔයාට බය වෙන්න කිසි දෙයක් නැහැ. හරිද? මේ පාඩමත් පුළුවන් කියන ළමයි ඕන එකක් ඔයාට පුළුවන්. Okay? Consistently වැඩ කරගෙන යන්න. Okay, because in our program we are finishing the syllabus in like you are 2027 January. Okay, so said you are having 7 months advance time. Okay, just to revise again the whole syllabus. Right? So it's a huge thing, huh? ඉතින් අපේ ප්‍රෝග්‍රෑම් එක හරියටම ෆලෝ කරගෙන යන්න පේපර් ක්ලාසස් ටිකට අනිවාර්යෙන් ඉන්න රිවිව් ලියන්න එන්න බැරි නම් රෙකෝඩින් එක හරි බලන්න. Okay, so we can make good results. Understood? So the answer is okay. So are there any problems, Lamai? I think all are okay with that. Okay, so this is a past paper question. Actually, this was there in your tute, your first atomic structure tute. We didn't do this question. Anyway, we are doing it here. So let's see how many of you got the correct answer. There are, I think, few students who got 50 out of 50. That means some of them got all questions correct. Fifth one, answer 4. See, only one got incorrect answer, but maybe by a mistake. Fifth one. So now let's review this one. So I'm going to tell you some statements in your printout. Write them in front. Okay. So this is a past paper MCQ in your new syllabus. Select the correct statement with regard to the particles associated with cathode rays observed in the cathode ray tube. So first of all, we must understand what these cathode rays are. So your answers are depending on that. So you have to remind that cathode rays are electrons. Okay. So let's underline the particles associated with cathode ray, that part, or highlight that part and write what is that? Electrons. Okay, electrons. So they are asking about electrons here. So the particles are uncharged. Is it correct? Are the electrons uncharged? No. electrons are negatively charged. There is a negative charge for the electrons. Okay, so therefore first one is incorrect. So you can say negatively charged. You can say negatively charged. Okay, you can say negatively charged. So fifth one, statement 1 is wrong. It is negatively charged. Negatively charged. Then you can say the second one, they travel from anode to cathode along straight lines. So what's the mistake there? Do they travel from anode to cathode or the other way? Huh? So why do we call them as cathode rays first place? Cathode rays can because they travel from cathode to anode. Understood? So see, they are nicely trying to misguide you. So anyway, it is wrong. Cathode rays are traveling from cathode to anode. Cathode to anode. So I'll give you into the next paper. මම ඊළඟ paper එකට දෙන්නම්. දැන් මම හෙට ඉඳන් තියෙන classes වල ඒකේ print එක දෙනවා. Right? A shadow question which is matching for this one from using anode rays. දැන් ඔයාලට මේක කියද්දි හිතනවා ඇති. Okay, what if this statement came for the anode rays? Is this true like that? You might thinking it is. So let's do a shadow question in our next class and see the same question, same structure, but the statements are a little bit changed. I'll ask that question for the anode rays. Okay, so this is there for the cathode rays, this question, and there will be a model question in your paper, next paper, for the anode rays. So then we can go to put these two together and get a very good revising from that. So cathode rays are traveling from cathode to anodes, not from anode to cathode. So let's see the third one. Their charge to mass ratio E over M depends on the nature of the gas and pressure inside the cathode ray tube. So it's wrong. Okay, so cathode rays are always electrons. Cathode rays are always what? Electrons. So it doesn't depend on the, okay, so does not depend on, so E over M ratio does not depend on type of gas, type of cathode, and pressure, voltage, anything else. So everything is not affecting the E over M ratio. This is a fixed value, constant value. Understood? So third one is also wrong, right? And let's go to the fourth. Their direction of travel is affected by magnetic and electrical field. That is true. You can write our favorite sentence. What is that? In our earlier classes, we kept writing that. Any charged particle deflects or change their path, deflects in electrical and magnetic field. Electrical and magnetic field. Okay, so the deflections you can remind. Okay, in electrical field they deflect towards the positive plate, and in magnetic field they deflect perpendicular according to the Fleming's left-hand rule. Okay, so fourth one is the answer, that is correct. So fifth, let's see why it is wrong. And they are not capable of ionizing the gas inside the cathode ray tube is wrong. Cathode rays are having some ionizing power. Okay, so cathode rays can ionize gas. Okay, let's say you had H2 gas. So first of all, it is broken into 2H. Then these H atoms will be ionized to H plus and electrons. Okay, then tell me what will happen to this H plus? What will happen to this H plus? If you use a perforated cathode, this H plus will give you what? Anode rays. So in our resource book, it is telling that already existing ions will give you the positive rays, right? Will generate the positive rays, and there is another method of generating positive rays by the collision of cathode rays. Okay, so there are actually two methods. So write it down properly. So cathode rays can ionize the gas. Okay, and it gives you anode rays, but only if you use a perforated cathode. Okay. Sixth one, oh my god, everybody got the proper correct answer. It's 100%. Okay, very good, very good. Okay, yeah, very nice. I'm truly happy. Okay, right. Balam, sixth. Okay. It's a statement regarding alpha, beta, and gamma radiation. Okay, so path of alpha rays are changed by magnetic fields. Path of alpha rays are changed by magnetic fields. Okay, path of alpha rays are changed by magnetic field. So that is true because charged particles will be deflecting. No? So you can write the second one is also true in the same way. You can say A and B are correct. Why? Because charged particles deflect in electrical and magnetic field. Okay, so you can say A and B are correct. But look at the third one. Third one. Third one. In third one, ionizing power of alpha, sorry, not alpha, it is gamma, right? Gamma is extremely high. No, gamma has the lowest ionizing power because gamma is very small, right? So therefore, it is very hard to knock electrons away from gaseous atoms. But the highest ionizing power will be therefore alpha because it is very large, relatively large. Okay, so you can write it down. C is wrong. C is wrong because why? Alpha is the one having higher ionizing power. Then D also wrong. Highest penetrating ability, that means ability to go through matter, is higher for gamma rays because gamma is so small and they are electromagnetic waves. It can penetrate through any matter. Okay, so gamma rays are having extremely high penetration power, not the alpha particles. Alpha has the minimum penetration power. So this is the table they asking in our tute. Remember, our tute එකේ තිබ්බ table එකෙන් පුතේ මේ අහන්නේ. ඒගොල්ලෝ හොඳයි හැමෝම answers දුන්නා. It's very good. A and B are correct. C and D are wrong. So they asking the correct statement. So answer will be A, B. So you have to select on the question type එකක් නේ. අපේ level paper එකේ. You have to select A, B correct, which means answer 1. Answer 1. Okay. Answer 1. Very good. Okay, seventh one about gold foil experiment. Most of you should have got the correct answer for that too. Let's see how many of you got the correct answer for the seventh one. Yeah, okay, 14 of you got the correct answer. Some of you took answer 1 and 2 also. Why? Okay, those who got answer 1, did you read the question carefully? It's asking the incorrect statement, so not the correct ones. Okay, they're asking for the wrong ones. Anyway, majority got the proper answer. We'll have a small discussion on that. It's about gold foil experiment from our few weeks back. We learned about that. So it's telling majority of the alpha particles penetrated the majority of the alpha particles penetrated the foil either undeflected or only with a slight deflection. Okay, because most of the space of the atom is empty. Okay, so that is true. That's why majority of the alpha particles pass through the gold foil. You remember there were 3 observations in the gold foil experiment. Majority pass through the gold foil without any problem. Okay, majority pass through the gold foil without any problem. This is the alpha particle source, and these alpha particles are coming very fast. Okay, they are actually accelerated alpha particles. Okay, so when they come fast, when they pass through the gold foil, it's very thin. I told you 1.5 micrometers. Okay, so Majority of them passed. So 9,990 passed. Why? Because according to the Rutherford model, most of the space of the atom is empty. This is empty. So then alpha particles can pass through it without any problem. Okay, so the first one, A, is correct. And look at the second one. Very few alpha particles bounce back in the direction from which it came, because those move towards the nucleus. Okay, only some of them, okay, bounce back. Okay, because they directly collided with the nucleus, or they were subjected to enormous repulsion from the nucleus. හරිද? repulsion එක මාර විදිහේ මේ nucleus එක මාර විදිහට repel කරලා තියෙනවා. ඒ හින්දා මේක අර bounce back වෙලා තියෙනවා. ඒක very few පොඩ්ඩයි එහෙම කළේ. Why? Because the nucleus is very very tiny thing. That's why only few were deflected. Okay, only few. මෙහෙම deflect උනේ නිකන් දෙකක් විතර when you pass 10,000. You remember the video we watched? Okay, so there also you had the same idea. Then look at the C. So anyway, A and B are correct now. Okay, but don't jump and select them, because they are not asking for the correct ones, they are asking for the incorrect ones. Let's see about statements E and D. A few alpha particles were deflected at a large angle because it experienced a large attractive force from positively charged nucleus. Okay, tell me, okay, put a message to the chat, why the C statement is wrong. Why the C statement is wrong. So I'll show you the C statement. Until that, tell me why C statement is wrong. Yeah, okay, very good. It is a repulsive force. Repulsive force. Okay, very good, very good, very good. It's a repulsive force, Lamai. Therefore, it is wrong. Okay, so it's very good, very good. So it's repulsive force. So underline that and write, it's not attractive force, it is a repulsive force. So when they pass closer to the nucleus, what will happen? They are repelled from the nucleus, because alpha particles are coming here, they are alpha 2,4. They have a positive 2 charge. So positive nucleus is also positive, therefore they repel from each other. Okay, so positive repulsion. Positive repulsion. Look at the last statement. Bohr model was disapproved by this experiment. Okay, Bohr model was disapproved by this experiment. So what do you think? Why it is correct? Incorrect? Why it is wrong? So which model was disapproved by this experiment? If it is not Bohr model, we haven't learned Bohr model yet. We are going to discuss it in next few weeks. Plum-Pudding model was disapproved. Okay, Plum-Pudding model was disapproved. So this model is named as planetary model or nuclear model. Planetary model or nuclear model. So it could disapproved Plum-Pudding model, which is given by Thomson. Okay, Thomson's model was disapproved. Okay, very good. Thank you for answering. So the incorrect answers are C and D. So the proper combination for the C and D is answer 3. Answer 3. So I'll show you it in the paper itself. Look at this. See, if it is C and D are the answers, you have to select answer 3. Okay, see here. Right. So there are 3 more questions. They are very short ones. We will quickly discuss them as well. Okay. So those are from first statement, second statement questions. Okay. So in that question type, first of all, you check the given first statement and see whether that is correct. Okay. Then you check the second statement separately. Don't think about the first one and just say whether the second one is correct. If both are correct, then you have to see whether the second one can explain the first one. Okay, depending on that, answer is going to be changed. You can see Answer 1 and 2 is having both are true. Okay, but depending on whether they explain or not, answer 1 and 2 is changing. Answer 1 and 2 are changing. Okay, now quickly see what is the first statement is telling. OH, OD minus and OH minus are isoelectronic species. Okay, first of all, define Puta what is isoelectronic species. 8. Isoelectronic means have same number of electrons. That is the meaning of isoelectronic. Same number of electrons are there. So let's see whether that is true. So let's take OH minus and OD minus. So OH minus, you are having oxygen with 8 electrons. Okay, oxygen you are having 8 electrons. From hydrogen you are having 1 electron, and with the negative charge you have another electron. So altogether you have 10 electrons. If you take OD minus, what is this OD? D is what? D is for deuterium. Deuterium is an isotope of hydrogen. It will have the same electronic configuration. Remember, we revised that last week also. So both are having the same electrons. So the reason must be, okay, D and H are isotopes. They have same number of electrons. Understood? So therefore they are isoelectronic species. That is true. See? Not that difficult, right? So make sure you get 10 electrons total count. Huh? When you're adding, you must add the negative charge also. Negative charge means some extra electron. Remember that. It will be needed for your next lesson. Unit 2 okay, it is needed for the unit 2. So remember, negative charge means an extra electron. Okay, so look at the second statement. First of all, see whether it is true, then decide. Okay, number of electrons in deuterium and hydrogen isotopes are equal. Yeah, very good. And that explains the first answer, right? Isn't it? So answer is going to be answer 1 for the question number 8. So let's see how many of you got it correct. Okay, very good. Out of 23 answers now I am having, 16 got the correct option and 5 of you got answer 2. So that happens, Lamai. Some of you still having the trouble, okay, whether it is deciding whether this is actually explains or not. That's totally fine. හරි දැන් සමහර අයට තාම තියෙනවා ඩවුට් එකක් අර එක්ස්ප්ලেইন කරනවද නැද්ද කියන එක හිතාගන්න කොහොමද කියලා. So you will understand it on the way, don't worry. ඒක කරගෙන යනකොට ඔයාලට තේරෙයි. Yes, it's fine. It's fine. Okay, so the 5 students who got answer 2 should write this can explain, second one can explain the first. Okay, and try to see the reason why second one can explain the first one, because they had isoelectronic, they were isoelectronic because why? Because they had same number of electrons, no? So if you take the two answers, minus charge and oxygen is common, only difference they are having is hydrogen and deuterium. So if they are having the same electrons, then they will have the same number of total electrons. Understood? So only explaining deuterium and hydrogen is enough. Okay, I'm telling this one for the students who took answer 2. Okay, so answer should be answer 1. මේකේ ළමයි මේ deuterium hydrogen ගැන විතරක් කිව්වම ඇති explain කරන්න. මොකද ඒ දෙන්නනේ මෙතන වෙනස් දෙන්න. අනිත් දෙන්න කොහොමත් එකයිනේ. ඔක්සිජන් උත් එකයි නෙගටිව් charge එකත් common. Clearද? ඒ හින්දා ඔක ගොඩක් අය කියන්නේ ඔතනදී මේ අනිත් දෙන්න ගැන කියලා නෑනේ කියලා. හරි අනිත් අය ගැන කියන්න ඕනේ නෑ, right? Oxygen and deuterium ගැන කිව්වම ඇති. Sorry, deuterium and hydrogen ගැන කිව්වම ඇති. Okay, so just think, okay, it should not be the actual like 100% true and on, right? But if it is nearly explaining it, still take answer as 1. Okay, so let's practice this one. Okay, in your next paper also there will be similar set of questions. You can understand that as well. Okay, we'll see. Don't worry, that still you are good, huh? Right. Because you figure out the statements are correct. Ne? That's a challenging thing. Perforated cathode is used, only positive rays can be observed. Yes, when perforated cathode ray is used, only positive rays can be observed. Okay, so no, you are observing anode rays as well. Sorry, cathode rays as well. Understood? So telling that you'll only see positive rays is wrong. Okay, so let's see the diagram once again. So let's say this is your cathode. These are the cathode rays. Okay, cathode rays are normally going towards the anode. There is no change. හරිද? Cathode rays are there. Cathode rays උත් මේක ඉන්නවා. But ළමයි anode rays හැදෙන්නේ perforate cathode එකක් තිබ්බොත් විතරයි මේ පැත්තට යනවා starting from the medium. So you'll see cathode and anode rays together. Anode rays together. Cathode rays and anode rays together in the same tube. So you can't see only one. හරි but ඔයාට cathode rays විතරක් නම් බලන්න පුළුවන් if you ignore the perforated cathode. يعني cathode එක perforate කරේ නැත්නම් ඔයා බලන්න වෙන්නේ cathode rays විතරයි. Write that too to your review. If cathode is not perforated, you can only observe cathode rays. If cathode is not perforated, write it down lama. If cathode is not perforated, you can only see cathode rays only. You can only see cathode rays. And let's go to the question once again. Look at the second statement. Look at the second statement. It is telling the charge over mass ratio, charge to mass ratio for positive rays depends on the type of gas used in the discharge tube. Charge to mass ratio depends on the type of gas used. Yeah, positive rays, their E over M ratio depends on the gas. So that is statement is true. Right? That statement is true. Just revise our earlier discussions, and in the paper classes also I have talked about that. So anyway, remember, since the particle is changing in the positive rays, their E over M ratio will be depending on the gas. Okay, so E over M for positive rays depends on gas. Depends on gas. Why it is depending on gas? Because for each gas, or you can say just the type of positive ray depends on the gas. Type of positive ray depends on the type of gas. So if you are having hydrogen gas, you get H plus. If you are having nitrogen gas, you get N plus or N2 plus or whatever. Understood? So it all depends on the type of gas we are having. Okay, is that clear to you all? So answer 1 is incorrect, answer 2 is correct. Answer 2 is correct. So your combination will be false and true. Answer 4. Answer 4 is there for the 9th question. Okay, so now we have come to the end of our discussion. Last question. Look at the question. Emission of gamma radiation from radioactive material. Emission of gamma radiation from radioactive material causes for the reduction of proton and nucleon number. No, it will not cause for the reduction of anything. Okay, so that one is wrong. You have to explain. See, okay, let's say carbon 614 is there. So if it is releasing gamma particle, it is still carbon 614. You can see gamma has no charge, no mass. Therefore, proton number and nucleon number will remain unchanged. Okay, so during gamma emission, proton and nucleon numbers are remain unchanged. Okay, So telling that it reduces or something is wrong. So we, okay lamai, just imagine if it is releasing an alpha particle, what will happen? If it is releasing an alpha particle, then their charge and mass, or you can say the new proton number and nucleon number will be changed, 4 and 10. So it's no longer carbon, it's going to be beryllium. Understood? So when alpha emission happens, this statement is true. What if a beta emission happens? Remember beta emission. If it is losing a beta particle, -1, 0, what will happen? Its proton number increases. Now it becomes nitrogen, 740. Okay. So I explained this one about beta emission in the class. Check your note. A neutron in the nucleus converted to a proton and an electron. Proton stays with the atom, increasing the proton number, and the electron converts to the beta particle. Okay, so neutron equals proton plus electron. That concept is applied here. Okay, one of the neutrons in the nucleus converted to a proton and electron. Proton stays in the nucleus and electron removed as a beta particle. That's the explanation. Okay. So like that, you can write these as well. You can comment on what happened to their nucleon number and proton number. It will be a good one. Okay. So අර review එක ලියද්දි මොනවද ලියන්න ඕනේ? සෙලම ලියන්න gamma emit කරාම මේක වෙන්නේ මේ change වෙන්නේ නැහැ කියලා ලියන්න. මේක explain කරන්න. Then explain about alpha and beta as well. Alpha emit කරොත් මොකද වෙන්නේ? Proton number, nucleon number දෙකම decrease වෙනවා. And beta emit කරොත් proton number increase වෙනවා, nucleon number change වෙන්නේ නැහැ. So can make a possible MCQs, right? You can give that point as a MCQ, like I gave here. In your future papers, similar questions will be there. Okay, and look at the next one. Look at the next one. Gamma rays are electromagnetic radiations. Yes, of course it is electromagnetic radiation. Right? And we will talk about electromagnetic radiation in our, not this week. After that, we are going to discuss about electromagnetic radiation. Okay, so I'll give you a proper idea, and it's a very interesting thing. Okay, you will see. Anyway, for now, from all level knowledge, you can say gamma is electromagnetic radiation. So first one is incorrect, second one is correct. Again, answer is answer 4. Okay, answer is answer 4. So let's see how many of you got the answer for the last 2 questions. For the 9th one, yeah, 17 of you got the correct answer. Some of you have selected the answer 2. 9th one. So that means you might have read it wrong. When a perforated cathode is used, only positive rays can be observed. Okay, අර මෙහෙමයි. ඔතන comma එකක පොඩි question එකක් තියෙනවා. If you put a comma like this, when a perforated cathode is used only, කියන තැනට comma එකක් දැම්මොත්, then that statement will be correct. Okay, so here there's no comma. Okay, so don't mind about that one much. Huh? So anyway, let's take the first statement wrong. Huh? So because some of you have selected it as correct. And last one, yeah, okay, 15 got the correct answer. Some of you have selected 1 and 2 as well. That means out of the 23 students answers, 6 have taken first one is true. Right? So that is wrong, Lama. Yeah? So study that. That's a good point. You can focus on that. Because when gamma emission happens, nothing changes. Only energy is emitted. Energy is decreased, not the matter. Understood that? Write it properly. During gamma emission, only energy is decreased. Only energy is decreased in the gamma emission. Okay, nothing else. Nothing else. Are there any questions? Okay, so be careful with the options and read the instructions that are given in the paper. In A-level paper, exactly similar question types will be coming. Okay, right? And yeah, today was a good discussion, right? So let's finish the class for today. Write a good review and bring those reviews with you when you are coming to our next class. And ළමයි හොඳට වැඩ කරන්න හැමෝම. හරි. ඔයාලන්ට පරිම දෙයක් කරගන්න පුළුවන් බය වෙන්න එපා. හොඳට reviews ලියන්න. Continuity is very important, right? So you have to continuously participate for the classes and continuously do the papers and collect them like I instructed at the beginning. Okay. And yeah, see you in the next class. I'll give you the next paper tomorrow and the next few days. Okay. Okay. Again, goodbye. Study well. If there are more questions, please send them as a message. Okay. I can answer.